Hello, everybody. I am proud to introduce to you my startup, Voxel, a tool to plan brain surgeries. Our mission is to create a visualization tool that visualizes the brain in 3 dimensions and helps surgeons treat brain diseases in 2 major ways. The first is to increase the accuracy of surgical planning, and the second is to improve surgical outcomes. Let's talk about the current standard. Today, prior to completing any brain surgery, surgeons plan the surgery by looking at CT scans and MRI scans. The problem is that these scans are 2-dimensional, and surgeons must often look at hundreds of scans in order to visualize one single brain. It is difficult for surgeons to look at 2-dimensional images and mentally reconstruct a 3-dimensional model. Viewing only 2D images causes delays in the surgical planning process, injects inaccuracies, and omits valuable information from the complete picture. Another problem that neurosurgeons face today is that their surgical planning process is not patient-specific. They use standardized images like these to draw on, discuss with, and eventually plan their surgeries with. Evidently, the brain of a 2-year-old child and a 45-year-old man would be very different, and it does not make sense to use a one-size-fits-all model as surgeons do currently. To combat the problems of current standards being only 2-dimensional and not patient-specific, we have come up with 2 different solutions. The first is to use 3D printing, and the second is to use virtual reality in order to visualize the brain. Our first solution encompasses taking the MRI and CT scans, constructing a 3-dimensional model of them, and then using 3D printing to print out that brain. This is especially useful in planning brain surgeries because it is a 1-to-1 model. The printed model is the same exact size as the patient's real brain. The surgeons can use the brain to draw on it, view it from various angles, and even resect parts of it. These printed models are also useful in educating the patients and their families about the surgery that will be taking place. Finally, various materials such as PLA, NinjaFlex, etc. can be used for various applications of the 3D printed model. Our second solution is to use virtual reality to visualize the brain in 3 dimensions. We've used the HTC Vive as our virtual reality platform and have written all of the code ourselves in MATLAB and C#. As you can see in this image, we have used intense algorithms to divide the brain into 6 different layers represented by 6 different colors. These include soft tissue, bone, gray matter, white matter, etc. The black dots are metal electrodes that the surgeons have placed in the brain. These distinctions between the different parts of the brain will help surgeons visualize the brain with more precision. Because this is all software-based, we enable in-depth analysis, instantaneous processing, easy manipulability, and allow surgeons to edit, save, and share their own virtual model of the patient's brain. Here we have a demo of our virtual reality system. You can free roam in the virtual reality world and view the brain from different angles. You can also take your controllers, walk up to the brain, and grip it so that you can move it in any direction you choose. You can also toggle between the 6 different layers of the brain to see different parts of it. And you can change the opacity of the brain as well if you want to give more emphasis to certain portions. We believe that we've created a really great first prototype for both the 3D printing and the virtual reality aspect of our startup. We're proud to say that surgeons at the hospital that we work with have already started using and loving our product. We've also received more than $20,000 in seed funding for our startup thus far. We hope to increase this number by the end of this year. Voxel has some big plans looking forward. Our product is currently focused on 3-dimensional visualization of the brain, but we can expand its use to visualize any bodily organ in 3 dimensions. This would assist in not only planning brain surgeries, but any kind of surgery for any bodily organ. Secondly, as we improve the 3D printing and virtual reality aspects of our startup, we also plan to add a third branch, augmented reality. The use of augmented reality will enable surgeons to perhaps see the patient's brain and the virtual brain at the same time, which would add a plethora of benefits. Finally, we're partnering with another company that will bring us the legal, financial, and business backing that me and my team of engineers do not have. Well, there you have it, an intuitive and interactive visualization tool that visualizes the brain in 3D using virtual reality and 3D printing. Can't wait to see where this goes next. Thank you.